Have you ever wondered about the science behind the beautiful light shows in the sky known as the polar lights? Well, you are in the right place. In today's episode, we will explore the inner workings of the sun, Earth's magnetic sphere, and the aurora lights. The northern lights, also known as the Aurora Borealis, are one of the most breathtaking natural phenomena on our planet. Paint the night sky with vivid colors and mesmerizing patterns, leaving observers in awe. While the beauty of the auroras captivates many, the science behind their creation is equally fascinating. This article delves into how the solar maximum influences the solar wind, how this interaction with Earth's magnetic field and atmosphere produces light, and why we are currently experiencing unusually intense northern lights. Additionally, we'll explore the phenomenon of auroral sounds, what people hear during strong northern lights, and highlight some of the best places to observe this phenomenon, including regions that are experiencing increased visibility due to heightened solar activity. The sun operates on an approximately 11-year cycle known as the solar cycle, during which solar activity waxes and wanes. The solar maximum is the period within this cycle characterized by the highest levels of solar activity, including increased numbers of sunspots, solar flares, and coronal mass ejections. During this time, the sun's magnetic field is most chaotic and dynamic. The sun is a really complicated celestial object. It's the center of our solar system and plays a vital role in humanity's history. That's why we have a dedicated video on our central star and NASA's cutting-edge Parker Solar Probe, which helped scientists explore and literally touch the sun. But how do solar particles reach our planet? Why doesn't this happen every day? And what defines the color of the light shows on Earth? Let's explore all of this. Solar wind is a continuous flow of charged particles, mainly electrons and protons, ejected from the sun's upper atmosphere, or corona. This wind travels through the solar system at speeds ranging from 300 to 800 kilometers per second. The solar wind is a critical component in the creation of the northern lights. When solar activity increases during the solar maximum, the intensity and frequency of the solar wind enhance, resulting in a greater influx of charged particles heading towards Earth. If you want to know more about the origins of the solar wind, check out our previous episode, where we discussed all the juicy science behind the sun's inner workings. It's time to highlight the hero of the story, Earth's magnetic field. As the solar wind approaches Earth, it encounters the planet's magnetic field. The magnetosphere acts as a protective shield, deflecting most of the charged particles away from the planet. However, some of these particles become trapped in the magnetosphere and are guided by the Earth's magnetic field lines toward the polar regions. The areas around the poles where the trapped particles converge are known as the auroral ovals. These ovals are roughly circular zones centered around the magnetic poles, where auroral activity is most frequent. The particles travel along the magnetic field lines and eventually collide with atoms and molecules in Earth's atmosphere, predominantly oxygen and nitrogen. When the charged particles from the solar wind collide with the atoms and molecules in Earth's atmosphere, they transfer energy to these atoms, exciting them to higher energy states. As the excited atoms return to their original lower energy states, they release the absorbed energy in the form of light. This process is known as atomic excitation and emission.